Okay, so bell ringer first. All right, on our first one, we have what is the difference in the means of school A and school B? When you added up the scores, or the reading times, I'm sorry, for school A, what sum did you get?
25.
You get 25. And we're going to divide it by how many numbers?
2.
And the mean is?
2.5.
2.5. Very good. Okay, do the same thing for B. SJ, what's the sum? 35 divided by, and you get?
3.5.
Excellent. All right, but the question asked for the difference in the means, so what do we need to do to finish it off? Millie? Subtract them. So 3.5 minus 2.5 gives us a difference of 1. Very good. Okay, the next question is similar to one of the ones that you did yesterday. On the test, it was one of the review questions. It was a graph, it was a dot plot with a couple, I think, basketball teams. And it asked about variation. Variation is similar to being consistent. They're opposites of each other. 21 out of 22 people got it correct. So that's really good. I only had one person miss it. And I'm still missing about 4 tests. If I'm checking for consistency or variability, what do I need to measure? What's the measurement I need, Millie?
The range.
I need the range. So on school A, what's the minimum and maximum that we're going to subtract? Millie?
5 and 0.
5 and 0, which is a range of 5. What about school B? Kate?
7 and 0.
7 and 0. Okay, so on this one, if I'm looking for the school that is more consistent, do I want the small range or the large range to be more consistent?
Small.
Yeah, I want the small one. On the test yesterday, it used the word variation, which sounds a lot like what word? Variability. So if I'm looking at variability, which team or which school has more variability?
School B.
School B. So more variability is a big range. More consistent is a small range. So kind of we got to keep those words together. Okay. We had 2 more bell ringers, 2 geometry ones. Let's start with the bottom one. And I do have a reason for that. The area of a square that has a perimeter of 36 centimeters. So we have a square. All sides are the same on the square. It says the perimeter is 36 and you are looking for the area. Okay?
For the area, I got 81.
Well, how are you going to get 81?
35 divided 36 by 4 to figure out what the sides were.
Okay, so 36 divided by 4 is?
9. No, wait, no, that's
Yeah, no, that's 9. And you said that's the length of each side. Okay?
And then I multiplied 9 times 9. That's 800, and I got 80.
Very good. So length times width gives you 81. 81 what?
Centimeters.
Centimeters area?
Squared.
Centimeters squared. Very good. Good deal. So, I mean, we've got a pretty good foundation on a lot of geometry, so hopefully that'll help when we start geometry right now, because that's what we're getting into. And the reason I wanted to wait on this first bell ringer is because these are the types of questions we're fixing to do today. So we'll do a bell ringer with them. And it's talking about a map scale. And it tells us that we have a map scale that is 1.5 inches is equal to 150 miles. When we do the problems that we're going to be doing today, I like to keep our stuff organized because if we put one number out of place, it's going to throw your whole problem out. Okay? And I use a method that I like to call WKU. It'll make sense, I promise. Okay? The W is where everything gets organized. It's our words. In this problem, our words would be our units. What are the two units in the problems?
Inches and miles.
Inches and miles. Okay, so I'm going to create a fraction ratio of inches over miles. This is going to keep my numbers in order because my inches numbers will remain on the top. My mile numbers will remain on the bottom. The K stands for what you know. We know the map scale. We know that 1.5 inches or 1.5 inches is ratioed to 150 miles. We know this because it tells us this. The U is the unknown. This is where my third number and my variable come up. The third number is 6 3/4 inches. So where will I put 6 3/4 in the fraction, Millie? On the top. And we can make it 6.75. And you're looking for the bottom. If we take the time to set our problems up, every problem will flow just like this today. Okay? And refresher on cross multiplying. We are going to multiply the two numbers that are diagonal to each other. So 150 times 6.75. And then divide it by the third number. And what fun, fantabulous answer do we get, Colby?
675 miles.
675 miles.
I think it's a different way.
Honestly, there is going to be a lot of ways to do these. I'm just going to pick one method and keep it consistent for my people who have to have everything exactly the same.
Yeah, because I did, I added 1.1.5, and I got 6, and I did that, but, I don't know, but I got the right answer.
You just went about it your way. And that's fine if it works for all the problems. I know that this method works for all the problems. Okay? Noel?
Doesn't it make sense for it to be 675 because 1.5 in decimal form is 1.5, which is basically 150. So 6.75 would be 675. Yeah, I'm just saying, it makes sense, you don't have to do that.
I'm still trying to figure out how 1.5 is basically 150, but
She's saying the numbers.
I know.
and I basically just knew the answer before I even worked it out.
Okay.
Well, whatever. I don't really know.
Okay. On your packets, just to keep things a little bit easier today and the upcoming weeks, I want you to take a minute and number the pages of your packet from 1 to 17. That includes front and back. The front is 1, the back is 2. I'm going to give you a minute on that and pause our timer. So now that you've numbered your packet and you see that we're going to solve problems involving scale drawings, just to throw you a couple brain teasers, the first two questions, the bottom of the page 1 and the top of page 2 are review questions. I'm going to give you about, 4 minutes to answer those two questions. Keep some things fresh in our minds.
What's the question?
The bottom of page 1, the top of page 2. It's a probability question and a wonderful fun-filled expression. All right, we're going to look at these practice problems right here. There are 10 cards in a bowl, and we want the probability that Andy will select a card with a 3-digit number. All right, probability of a 3-digit number. How many 3-digit numbers are there, Munir? 4 out of? Sir?
10.
4 out of 10. And that reduces to which of these fabulous answers? A is correct. What is that as a percent? Percent. 40%. Very good. 0.4 is the decimal. Okay, we have our expression. All right, Noelle.
Wait. So I did 4 times n, and 4 n plus 4 times 0.75, which is 3. So 4 n plus 3, and then I got half of 12 is 6, and then half of 36 is 18. But you change the minus sign to the plus sign, and then you make negative 12, and make the minus sign in the parentheses a plus sign.
Very good.
And then
So you have minus 6n and plus 18.
Mhm.
I love that you remembered to change those signs.
And then you do 4n minus 6n, or plus negative 6n.
Okay.
And then you would do positive 3 plus 18. So you would get negative 2n plus 12.
Very good. Great job with those negatives. Okay, here we go into scale and scale drawings and scale factor, but we're not talking about the scale that weighs us, okay? We're talking about the scale that compares models to what they're representing, or a drawing to what it represents. This is really important for people who go into architecture or engineering, those types of fields. They do have to have an understanding of these ratios, because you don't want your building to come out wrong. Okay, it could be a structural hazard. But scales compare the two things. You have them on the maps, like what the bell ringer was. So in your history class, if you're looking in maps, or when you take geography next year, it could say like 1 centimeter equals 150 miles on the map. And so if we were to measure in centimeters between 2 points, we could find an estimation of how far they are. That's what we're doing. And then also looking at scale drawings. Y'all take enough selfies, believe me. All right. And those are reduced pictures of you, correct? I mean, obviously, Munir's picture on his cell phone is not, 5'8" or whatever size however height he is. It's gonna fit on his little, 4 to 6 inch screen. So it's a shrunken version of him, just like all your photos are. But they have to be similar. That's gonna be important. And what I have written on the screen is that when things are similar, we're talking about them being proportional. That's when we get into our cross multiplying. So we're going to be getting into this and setting things up so that we can cross multiply to find our different answers. Sound like a plan? Yes. All right. We're going to start with some easy ones, just like the bell ringer. And we got a couple scale factor practices. And I'm going to set them up just like we did the bell ringer, just to practice a method. Yes, I know we're going to see answers in different ways, and that's fine. Okay? But this method keeps it consistent for all these types of questions. And our first letter is W. My words, my units. And I'm going to find that on the map scale. What are my 2 units? Feet and miles. And what I like about this is you can do feet and miles, and I could do miles and feet, and we'd still get the same answer. So it kind of helps clear up a little bit of possible misconception here. Okay, so feet and miles. My next one is the K. What do I know? I'm going to get that from that map scale as well. Now I'm going to go with my numbers. How many feet to how many miles? Millie?
2 feet is 1.4 miles.
Okay, so 2 feet. 2's on the top with the feet. 10.4 is on the bottom with the miles. And my last is the U, the unknown. I'll have one number and one variable.
How many feet is 20.8?
Okay, so how many feet is 20.8 miles? So the 20.8 will be top or bottom? Bottom. That's one reason I like you guys to do those words first. And you're looking for your top number. Once it's set up, you can visualize your answer however you see it.
Couldn't you kind of just like do this on your own though? It's 10.4 times.
Like I said, there's going to be lots of people who see a lot of different things, and then some people just need consistency.
I don't get it.
You don't get how we set it up?
Well, I kind of.
Okay.
So it's the measurement over the answer.
It's the feet over the miles. Like I'm comparing feet to miles on this scale.
But what if it was a different measurement?
Then you would just use different measures. The next one uses meters and miles.
Oh,
We just use what we're given.
so miles is always on the bottom.
I can put it on top and still get the same answer.
How? Oh,
Because when you cross multiply, if I were to flip this entire problem,
You can still multiply the same numbers.
it would still multiply out. I'll flip it upside down real quick. Like I said, all of a sudden people are like, I don't know what to put on top, what on bottom. Well, it really doesn't matter. What matters is that you keep the numbers in line. My top would now be 10.4 miles to 2 feet. And then over here, I'd have 20.8 miles, and I'm looking for feet. On both of these, I'm multiplying the same two numbers and dividing by 10.4. So it kind of is going to help us eliminate those possible errors that we could come up. What answer do we have? I'll just leave that there for now. SJ? 4 is correct. I'm going to get this bottom one off. All right, 4 is our correct answer. And we go to our next one. The map of a scale is 5 meters equals 15 miles. So starting with our words, what are those units? Millie?
Meters over miles.
Meters over miles. Next is the K. What ratio do we know meters over miles? Millie?
5 over 50.
5 over 15. And the U is the unknown. So I know one number and the other part gets the variable. My other number is 7.8. Lawson, where does it go? 7.8 on top. You're looking for the bottom. You get to do your cross multiplying. Colby,
I got 22.4 miles.
what was it?
23.4 miles.
23.4. Very good. And the first one was 4. I just like to keep consistency. I think it kind of just helps a little bit. But you do you, as long as it works every time. All right. This one, the first one, the map of a scale is 2 meters equals 4 miles. So if I start the same way in words, what are my units? And what are my units on this one? Miles to meters. So, I'm going to put miles on top just because that's the order you gave it to me in. I'm going to be difficult. Clara, she did miles over meters. So what number of miles goes with how many meters?
4 miles goes with 2 meters.
4 miles goes with 2 meters. That's my known. And now the unknown part. What number goes the where and the variable? Okay.
It's all goes at the bottom.
The 12 goes on the bottom with the meters, and you're looking for the miles. If yours is reversed the other way, that is fine. Because no matter what answer should you end up with? The correct one. Clara? 24 is the answer we should have ended up with. Okay, so Noelle, just because, what's the answer on the next one? Without mathing, don't math.
40.1.
Why is it 40.1 without math?
There's 4 kilometers equals 4 miles, and it's the same.
Yeah, if your scale is the same for both of them, it's going to be the same for everything. So some of these, yes, common sense, use it. Okay, some of them, like on I think the second one we did, when we start throwing decimals in, they may not be as noticeable.
How do you get 40.1?
It's just as she said, on here, when you look at the scale, the miles and the kilometers are going to be the same number.
So how do you get 0.1?
Because it gave us down here in the question. You can set it up kilometers to miles. 4 kilometers is 4 miles. We know 40.1 miles. You're looking for the kilometers. And in fractions, if the top and the bottom are the same, they're always going to be the same, no matter what it becomes. All right, give you about 2 minutes on these next 2 questions, and we'll get some people to explain. Okay, so Colby, you want the first one. So what did you do? And kind of explain it so that those who are not in class can understand it.
So I did my W and I did miles over meters.
Okay, so miles over meters.
And then my node was 4 over 18.
Okay, so you did meters over miles.
Oh, yeah, that's right.
Okay, let me correct that then. Meters over miles, and your known was 4 over 18.
And my U was 6.8 over X.
Very good.
And so I multiplied 18 times 6.8 and got 122.4 and divided that by 4 and I got 30.6 miles.
30.6 miles. Very good. Okay.
I did, for my W, I did feet over miles.
Okay, Lucy did feet over miles. Good.
And then for my known, I did 4 over 16.
Correct.
For my U, I did X over 80.
Very good.
And then I did 80 times 4 divided by 16, and I got 20.
Got 20 feet. Very good. Very good. So we good so far on this? Kind of simple. Until we throw word problems in like the next one. Oh, snap. Okay, so we're going to keep the same thing. And just like in the way we were doing it, if we just follow our same pattern, we're going to get the answer every time. So on this one, it says that the map key shows that a distance of 1/4 inch represents an actual distance of 5/8 miles. This first sentence that they've given you is what you know. So I can start with this. What are the words we're given, the units?
Inches over miles.
Okay, we've got inches and miles. And what is the known?
1/4.
Okay, so 1/4 of an inch, 5/8 of a mile. We can turn those to decimals. They terminate. So 0.25 inch to 0.625 miles. Now the unknown, what they're asking us to find. What's the third number we're going to need?
1 over X.
The 1, and it's an inch, so it goes to the top, and you're looking for your miles. Anybody with an answer now that you've had a chance to look at it? Lawson.
2.5.
2.5 is the correct answer. Good job.
Wait, 2.5 miles?
Yes, 2.5 miles. Oh, we're getting really particular now.
I was just confused.
Get those units on there. I love it. Very good. Okay. Here's another one. I'm going to give you a minute to do this one. In the problem, it gives you the scale of a map with the key 1/4 inch equals 2.5 miles. That's your starting point. Give you about, I don't know, minute. All right, SJ, help us out here.
You gotta do WKU.
Okay, so you said WKU? All right.
And then you gotta do inches over miles.
Okay, inches over miles.
And then 0.25 over 2.5.
Okay, 0.25 over 2.5.
And then it's a 1, so you put 1 on the top.
Well, what's the reason we're putting the 1 on the top?
I thought it was because like it's like a lower number. That's all.
It's because it's inches. That what we write down in the W needs to keep our numbers in order. Because if it would have said 1 mile, it would have had to pop down to the bottom.
Then you do 2.5 times 1 divided by 0.25. You do 10.
Very good. 10 miles is the correct answer. Very good. Yes, sir. Absolutely. Okay, so now here's a couple more questions we're going to do. Let's see, what page are we on right now?
6.
We're on page 6. All right, I want you to do this one because then I'm going to have you actually find a scale. So I'm going to give you a second on this one. Okay, who's got this one? Oh, let's find random people. Cameron. Hi, Cameron. I think you need to answer this one for me and set it up, please.
Okay. So we got
Hey, folks, all your chatting's being picked up. I need to catch Cameron's voice on this.
yeah. They need me. So we got CM over M.
Very good. CM over M, because they've given you 1 centimeter is 2.5 meters. Okay, so CM over M. That's my words. Okay? The known. Where you got your centimeters and meters, what's the number ratio that we're going to start with?
Is it 4?
No, it's what I have highlighted in purple.
Okay.
That's our starting point.
Okay, I knew that. Yeah, 1 centimeter over 2.5 meters.
1 centimeter and then 2.5 meters. Very good. Now we're going to come into the unknown, the part that we're looking for. That would be that third number, 4 centimeters.
I'm trying to do this, yeah. Okay.
Would it go top or bottom since it says centimeters?
Top. Top.
It's going to go on the top. 4 centimeters. Centimeters are on the top. 4 on the top. And you're looking for the bottom value.
I'm gonna do it.
Legend. Cameron set it up beautifully for you. Did you do the same thing? What'd you get for your answer? 10 meters. Perfect. Okay. So the next question underneath that one is some box cars from a train. Says the actual length of a box car is 609 inches. So this picture is showing us an actual measurement, 609. The 7 inches is the model. Okay? We good so far? We have a model and we have the actual box car. we're being asked to find the scale. We're going to set it up just like we've been doing. We want to compare the model to the actual. The model is measured in inches. The actual boxcar is measured in inches. That's why I'm giving us different words. We're told the model is 7 inches. The actual is 609 inches. In order to find the scale, you want to find the model for 1. You want the model to be a 1. So for every 1 inch of the model represents how many inches on the actual boxcar. So we set it up exactly the same way. We cross multiply it out.
87.
Okay, we get 87. So we would say our scale is 1 inch equals 87 inches. Okay, so when we're looking for the scale, the smaller thing needs to be, we want to get it down to a 1. Every 1 inch on our small thing equals so many measurements on the bigger thing. We're going to do another one. Okay, turn our packet up. That was it. That is it. So we're going to do another one. And it gave us an architectural drawing. And we have the drawing on the left, and we have the actual room measurements on the right. We're needing to find the scale. So we're going to compare the drawing to the actual room. What's my first ratio for my drawing to the actual room?
10 over 160.
Okay, 10 over 160. Now, to find scale, I need a 1. Is the actual room or the drawing of the room going to be the 1? The drawing is going to be the 1. And you're looking for that, how much 1 represents on the bigger picture. Jataya? 16. So my scale would be 1 inch equals 16 inches.
So
So-
it's 160 divided by 10.
Part, yeah, ultimately, yes. The actual divided by the model or the drawing is going to get us that. We're really looking for a unit rate, kind of. I mean, your scale is a unit rate. That's kind of really what you can relate it back to. How about some sailboats? You want to make a scale model of a sailboat that is 51 feet long and 48 feet tall. You plan to make the model 17 inches long. What is the height of the model? And then we're also going to find the scale. Okay? You need to find the two numbers that are related to each other in here. Millie, what two numbers are related to each other?
Is it the 51 feet long and a 17 inches?
Yes. Why are the 51 and the 17 related?
Because they're both long.
They're both talking about the length. So these two numbers are going to be our starting point. So when we do our words, we're going to have inches and feet. What's our known relationship here on inches to feet? 17 and 51. Very good. The unknown is when that 48 feet tall comes in. Well, where will that 48 go? on the bottom with the feet. And you're going to find out how tall the model is. So we're going to cross multiply. 48 times 17. Divide that by 51. And how tall? 16 inches.
So same thing, just different words.
Yep, exactly. It's all about finding the relationships here. Now, how would I find the scale? I told you guys we were going to find the scale on this as well. Remember, on the scale, you want to compare what? We need to find for a 1. But remember, we're gonna compare the model to the actual. The model is measured in inches. The actual boat's measured in feet. So can we use what we started with? Millie? Yeah. We can start with the 17 and 51 again. But this time, what's our third number since we're looking to create the scale? When we're looking for scale, go back to the 2 questions beforehand. When I'm looking for scale, what's the number in the unknown section? It's a 1. When you're looking for a scale, you're going to be using a 1 in your model. We're going to find that our scale is 1 inch is equal to how many feet? Lawson. 3 feet. Okay, so we got to keep 2 things in mind here, okay? If I'm asking you for one of the measurements, we're still cross multiplying. If I'm asking you for scale, we're still cross multiplying, but that third number involved is a 1. And that's going to be kind of our little tricky part here. All right. You ready for your bad drawings? Yes. They gave you bad drawings. Usually, if it's a word problem, I'd say draw stick figures and label them. Okay? These are my shadow questions. And these types of questions, as just a bit of a heads up, have been seen on the ACT. Okay? I know because I'm tutoring someone on the ACT right now. And these are, she remembers these one of the times she took the ACT. They're also in the ACT review questions. Okay? So it's kind of valuable. And it's actually a logical way to measure things. Like strange things. Like the height of a telephone pole. Like things that are really hard to measure. You can use shadows to do it. Okay? It's all proportional. Your shadow is proportional to you at different times of the day. It's really cool.
I've seen those things. It's like you have to stand wherever you are and it'll tell you what time it is.
Oh, yeah, that's a clock. That's a solar clock. A sundial. Okay, so on this one, I say draw the pictures because we're going to label the pictures. It says that the giraffe is 18 feet tall. Well, from foot to the top of his head is going to be 18 feet. So I'm labeling that an 18 because it runs up and down. He casts a shadow of 12 feet. The shadow is going to be on the bottom. So I'm labeling that bottom line at 12. Corey casts a shadow of 4 feet. Where's Corey's shadow? On the bottom, on the ground. We're trying to figure out how tall Corey is, so I don't know how tall Corey is. I love the pictures because if you visualize it, the 18 falls on top of the 12, the X falls on top of the 4, and now we have it cross multiplying again. X over 4, 18 over 12, and we are back to exactly what we've been doing in all the other previous problems. Cameron.
Why none of our pictures ever have colors?
Because it would be really expensive for me to do
Well, yeah,
130 packets in color.
Yeah,
That'd be a lot of
The
expense.
packets are easier than like, because you can like review it without having to find the pages.
True.
you could just
All right,
do mine.
Kate,
I got 6 feet.
6 feet tall would be the correct answer.
Do rest of color.
All right, how about a Ferris wheel? This could be a legit question. You could take a man's height with his shadow and then the shadow of a Ferris wheel and estimate how tall that Ferris wheel is. You can do that. Seriously.
Why don't you just like measure it?
Because people are weird and need to know strange things. You might want to know how tall a tree is. So,
Why don't you just like measure it?
So you
Like,
stand
can you climb to the very, very top of a tree?
It
Yeah.
matters how tall the tree is.
Exactly. So instead, we're going to use your height and shadow and the tree shadow.
Bucket truck thing.
If you're by yourself, how are you gonna measure it? Do you like stand there and like throw the ruler?
Yes. No, it takes multiple people, silly. Okay, so a Ferris wheel casts a 20-meter shadow. So there's my 20-meter shadow. A man who is 1.8 meters tall casts a 2.4-meter shadow. So all I've done is labeled my pictures. And we're trying to figure out how tall the Ferris wheel is. It's like the last one, the heights go down on top of the shadows. So x over 20, 1.8 over 2.4. Lucy?
You guys only have to first.
Yeah, how tall is the Ferris wheel?
15 meters.
15 meters.
My question is, how can it cast a larger shadow of it?
It's the angle of the sun. At certain times of the day, depending on how either it's rising or setting, your shadow is going to elongate. Okay.
Would you, like, not have a shadow?
Yeah, if it's perfect noon, your shadow's straight underneath you.
So it'd be 0 meters.
Yeah, it's kind of cool.
It wouldn't be tall.
Okay, Kate, bring these packets with you Monday. I'll upload this to Canvas for reminders. Your assignment Monday is going to focus on these skills, okay? All right, I'll see you guys Tuesday. Okay, so even though we just ended class, I wanted to do a couple more with those that are either still having a couple issues with this or aren't in class. On this one, we have a flagpole that casts a shadow that is 28 feet long. So we're going to put the shadow for the flagpole as 28. And then we have a person standing nearby casts a shadow of 8 feet long. So the lady's shadow is going to be 8 feet. And it says that the person is 6 feet tall. So her height is 6 feet. And we're looking for the height of the flagpole. Just like we've been doing all the other problems, if you take the height and put it over the shadow, so height over shadow, you're going to end up with another proportion. So you can still keep with your words, height over shadow. We start with the flagpole. The flagpole's height is 8. Its shadow is 28. The woman's height is 6. Her shadow is 8. And then we're back to something that we're going to be able to cross multiply. And I know I have a couple people still struggling with cross multiplying. So with cross multiplying, you want to take the two numbers that are diagonal to each other. So 28 and 6, and we're going to multiply them together. So 28 times 6 is 168. We're going to take the 168 and we're going to divide it by the leftover number, which is 8. So 168 divided by 8 is 21. So the height of the flagpole is 21 feet. On the next one, we have a photograph that is measuring 4 inches wide and 5 inches long. So we're going to take the little dog in the dress, and we're going to have 4 inches wide and 5 inches long. And it's going to be enlarged to make the wall mural, so the bigger picture. And this one says if the mural is 120 inches wide. Now this is where we need to make sure that we label things right. If we go back to the photograph is 4 inches wide. So the 120 needs to be in the same spot as the 4. So I'm going to put the 120 on the side. We're looking for how long it is. So just like the shadow pictures, we've set ourselves up a part where we can just put the width over the length. So how wide it is over how long it is. And on the picture, 4 wide, 5 long. On the mural, 120 wide, and we're looking for how long it is. So we're going to cross multiply. 120 times 5, and then we're going to divide it by 4. So 120 times 5 is 600. And then if I take the 600 and divide it by 4, I get 150. So our missing value is 150 inches. Okay, same idea. We have a 9-foot ladder. It leans against a building that is 6 feet above the ground. At what height would a 15-foot ladder touch the building if both ladders are the same distance or form the same angle with the ground? Ooh, that's some bad typing. Okay, so we have a 9-foot ladder that is 6 feet above the ground. So we have the ladder and its distance above the ground. On the first one, so on number 1, we have a 9-foot ladder that is 6 feet above the ground. On number 2, we have a 15-foot ladder, and we're trying to figure out how far it would be above the ground. We're going to cross multiply again, so 15 times 6, and we're going to divide that by 9. 15 times 6 is 90. Whoop. So 90. We divide that by 9, and we find out that it is 10 feet above the ground. I hope this helps a little bit more with some of the things that we're doing. Use the notes from this packet, use what we've done on this video, and all of this is what you're going to be practicing on Edge Elastic on Monday when I am out. So it's going to be a good idea to have your notes nearby and review over this if you need it. Any questions will be answered on Tuesday when I return to class. Have a great weekend.